Okay, carrying on here, we have a to the m over a to the n. So now division, and if you remember from your exponential rules, that's the same as a to the m minus n. I always like to show here that that's why, say a to the fifth over a to the fifth. If we use that rule, 5 minus 5 is 0, so a to the 0 power is equal to 1, which you knew that a to the fifth over a to the fifth was 1 anyway, so it's just a nice little tie in there. Okay, but basically when we divide powers of like bases, remember we subtract. Don't make fun of my writing on this. The exponents. Okay, so straightforward algebraic example. Obviously, we get x to the third power, 7 minus 4, and we get 3. A not so straightforward, but see if you can follow this example here. This one's definitely a little uglier, but think about like bases here. So we got 27, we got 27. Definitely could, square root of 27, what is that? Well, I can think about it, and there's multiple ways to kind of think about this problem, but you can think about it like that. And then the sixth root of 3 cubed. Isn't 3 cubed the same as 27? So this does say that right there. But I'm trying to get the like bases with, exponents so I can actually do the subtraction property. So this is really going to be 3. Well, remember, this is a little 2 right here. If you don't see it, it's a 2. So if, that's actually to the 1/2 power. So there's already a 3 there. This is really 3 to the 3/2 power. Based on, if you need help with that, go back up to here and go through that thought process. But on the bottom here, we've got 3 to the, what is this? The 6th root, so 3 over 6, which obviously reduces to 1. I can just write it 1 over 2. Okay, so what does that become? Well, that's going to become 3, the same bases, and then 3/2 minus 1/2. Well, 3/2 is 1.5 minus 1/2 is just 1. So if we do the subtraction rule here, we get 3 to the first power, which is actually just 3. So that whole thing right there is actually just the number 3. How fun was that? All right, again, we're going to think of things differently, that's all, okay? So we're going to think about these things differently. So I want you to think about this one right here as being 1 over e and then times e to the x power. So the basic exponential function with base e, can you think of that as 1 over e times that? Take a second, soak that in. That's the exact same thing, right? So what we have here is we have the exponential, okay, exponential base e, right? But what do we have? We have a vertical stretch. So vertical stretch of what? Oh, actually, I should use a different word there. I should undo that, and hopefully you can think about what word I'm going to use. If there's a fraction with a vertical maneuver, remember, that would be a compression. So vertical compression of 1 over e. Well, what is that equivalent to? Well, I want to go back here and get you to think about this as the subtraction rule that we just talked about. So that would be x minus 1. So that's actually equal to e raised to the x minus 1. Now, if I was in class with you right now, we would probably go graph these to show that they're the same. Okay, but they are the same. So e to the x minus 1 is the same as this right here. So basically, what is the exponent base e vertical compression of 1 over e equal to? That's, basically the exponential function base e shifted right 1. Okay, so all of that hopefully is kind of going together there, and that's making sense. All right, I'm going to keep going with this one. Hopefully the video won't be too long here to upload, but we'll keep going. All right, so this one right here, if you remember, all we have to do when we have a power of a power, as we call it, is we have to multiply those exponents together. Easily shown if you just think about x to the third. Actually, let's do this. X to the fifth to the third. Just think about it. That really means x to the fifth times x to the fifth times x to the fifth. There's 15 x's there. All right. So I don't want you just to memorize rules. I like you to think about them. So multiply the exponents when you have that situation. Okay, so obviously this is going to be x to the 28th power based on what I just kind of set up on that one. And then this one here would be 8 to the 15 over 6th power, right? So what would that be? That would reduce to 8 to the divide by 3. We're going to get 5 halves power, which is actually going to be equal to, sorry, take a 3 out. That would be, yeah, is that 15/6 there? Yeah. Take a, sorry, I'm going too fast for myself here. Take a 5, can't take a 5 out. Take a 3 out. 3 out, 5, 3 out, 2. Good, sorry. And then I'm going to get, well, I could do the second root of 8 to the 5th power, or I could do the, actually, I think what we really wanted was for this one to come out a little bit nicer. I want you to think about that. If this came out to a cube root, then we'd be able to do the cube root of 8, which is 2, and raise that to the 5th power. But since this is coming out to a square root, this is going to be definitely a little bit uglier to do by that method. I mean, we could do it. You'd have to think about it as the square root of 8 to the 5th power. Again, as you can see, if that was a third root, cube root, that would be a lot easier because we'd get 2 raised to the 5th, but we can still do it. So that would be, you know, square root of 8 is 2 root 2, and that would be raised to the 5th power. All right, so then that would be, I'm sorry, 2 to the 5th is 32. And then root 2 to the 5th would be root 2 times root 2 times, 5 times. So root 2 times root 2 is 2. Root 2 times root 2 is 2. So that's going to be times 4. And there will be 1 root 2 left. So 32 times 4, we're going to get 128. Root 2. All right, I'm doing this one on the fly because I think we want that to come out a little different, but don't get caught up in that. Hopefully some of the exponential rules and roots work there. All right, so now back to the nuts and the bolts of it, of what we want you to really see. So this right here, obviously starting off, you can quickly see exponential base 9. Okay, no transformations, exponential base 9. Like, what's that equivalent to? All right, well, that, obviously, base 3 could be written as, 3 squared times 3 to the what power? Well, that would be x, right? Would that be the same thing as 3? Whoops, sorry, let me back it up. I'm going to show you this. Sorry. Let me back it up. Now my video is getting too long. Sorry. Let's do it this way. All right, let's do 3 squared, like that. Let's break it down like this. So that is the same thing as 9 to the x power, obviously. So then we can use our power rule. That's what I wanted to show you here, sorry. That would be 3 to the 2x power. So exponential base 9 is equivalent to exponential base 3, and remember that's the horizontal stretch or compression, and then it's backwards in there. So since we have a nice integer here, that would actually be called a compression. So base 3 compression, by a factor of 2, you would say that. I'm running out of room. Okay, so basically what we're gonna do here, the whole idea is, well, let me cut this one short, and I'm gonna stop the video here, get you to another one.